beneath the seemingly serene landscapes that span the Earth's crust, titanic forces brew with the potency to upend worlds. Imagine waking to a morning where the ground itself has turned traitor, undulating with such violence that it devastates millennia of human progress in mere moments. This is the stark and sobering reality of earthquakes and tsunamis, nature's twin disasters that can, without a whisper of warning, alter the course of history. Recorded through time, from the destruction of the advanced Minoan civilization by a colossal tsunami in 1500 BCE, to the 2011 Tohoku earthquake and tsunami that rattled the world. These phenomena whisper warnings of Earth's unchecked power.
Indeed, history serves as a stark reminder of the sheer force these natural events wield. They echo through time, urging us to heed their lessons and prepare for their inevitable recurrence.
Earthquakes manifest as the Earth's crust, a patchwork of tectonic plates, shifts, and grinds. These movements occur at the borders where plates meet, often causing seismic activities. The energy that triggers an earthquake is released when the stress accumulated along a fault line overcomes the friction holding the rocks together, allowing them to snap into new positions. This violent release of energy sends shockwaves, or seismic waves, radiating out from the epicenter, shaking the ground. Geoscientists have classified fault movements into three main types: normal, reverse, and strike-slip, each defined by the direction of the force and movement of the Earth. As plates interact, they build up kinetic energy that, when released, dictates the intensity and the reach of the quake. It is this intricate geological choreography that was at play during the infamous San Francisco earthquake of 1906, a disaster that remains a touchstone in the study of seismic activities. Advanced methodologies, including GPS and satellite technologies, now allow scientists to monitor these tectonic movements with unprecedented precision. Efforts to understand the mechanistic underpinnings of earthquakes lead to better forecasts and preparations, though the exact prediction of when and where an earthquake will occur remains elusive. Nevertheless, this growing body of knowledge is crucial in building structures designed to withstand the tremors, thereby helping to safeguard lives and infrastructures.
The dance of the tectonic plates is a fascinating, albeit dangerous, ballet. By understanding how these plates move and interact, we can better prepare for the inevitable quakes and minimize their impacts on our world.
Imagine waking to a morning where the ground itself has turned traitor, undulating with such violence that it devastates millennia of human progress in mere moments.
Living in an area prone to earthquakes, you learn to respect the power of the Earth. Every tremor is a reminder of nature's might and the importance of being prepared.
Following the seismic drama beneath the Earth's surface, another monster can emerge in the ocean. Tsunamis are prodigious waves caused primarily by undersea earthquakes.
When tectonic plates abruptly shift or a seafloor deforms, it displaces massive volumes of water, unleashing waves that travel across oceans at the speed of a jet plane. The energy of a tsunami is enormous, and its destruction, profound as it nears the coast.
The anatomy of these waves involves a complex interplay of energy dispersal, water column displacement, and crucially, the bathymetry of the seabed. As these colossal waves approach shallow waters, their speed decreases, but their amplitude increases, causing them to rise dramatically, a phenomenon known as wave shoaling.
The 2004 Indian Ocean tsunami, triggered by one of the largest earthquakes ever recorded on a seismograph, demonstrated the terrifying power of such phenomena. The waves reached heights of over 30 feet, devastating coastlines and communities from Indonesia to the distant shores of Africa and leading to significant loss of life and irreversible changes to ecosystems and human settlements.
Despite their ferocity, tsunamis offer slight windows for preparation, unlike earthquakes. Tsunami warning systems, using undersea buoys and tide gauges, help in providing critical minutes for evacuation. Enhancements in these systems continue as part of global efforts to mitigate their impact.
The waves reached heights of over 30 feet, devastating coastlines and communities from Indonesia to the distant shores of Africa, and leading to significant loss of life and irreversible changes to ecosystems and human settlements.
The interplay between earth sciences and technology is defining modern approaches to disaster readiness. Today, sophisticated seismic networks, high-speed data analytics, and simulation software form the backbone of earthquake and tsunami forecasts.
Efforts are continuously underway to integrate artificial intelligence with these tools, improving the speed and accuracy of data interpretation. Initiatives like Japan's Earthquake Early Warning (EEW) system exemplify how technology saves lives.
The system detects seismic activity and broadcasts warnings to the public through television, radio, and mobile phones seconds before the shaking starts. This warning can provide precious time for people to seek safety. Community-based preparedness programs also play a vital role in enhancing resilience.
In regions prone to these disasters, educational programs and drills help individuals know how to respond when the warnings come. Moreover, engineering standards have evolved to require that buildings and infrastructure be designed to endure geological stresses, reducing potential devastation.
The effectiveness of these technologies and strategies was vividly displayed during the 2011 Tohoku disaster. Despite the massive scale of the earthquake and tsunami, advancements in preparedness and response technologies helped save many lives and highlighted areas for future improvement. In closing, while the ultimate mastery over such formidable natural forces remains beyond our reach, the burgeoning field of geotechnological applications offers a beacon of hope. Through the continuous improvement of detection systems, structural engineering, and community education, humanity stands not as a victim, but as a resilient contender in the face of Earth's furious might. The complexity of earthquakes and tsunamis intertwines geological science with human innovation, highlighting a story of survival, adaptation, and respect for the planet's awe-inspiring power.